So this is where we're headed with this next problem. I want to back up a little bit and kind of explain all the artwork. So here's the second example. When I solve a system of equations by substitution, I didn't mention this in the previous example, but I do like to have the equations written side by side because, as you just saw, all the work is happening below the equations. When in this example, neither of the equations I have is already solved for a variable. So I have to decide which equation do I want to work with first and what variable do I want to solve for. This is just a personal choice. You just go with whatever just feels easiest to you. In my mind, it's easiest to solve this equation for y. So that's what I decided to do. I added y to both sides, so that means that canceled out and y is here. And then I subtracted 4 from both sides, so he canceled out and moves over to this side. So now I know that this little expression right here is equal to y. They're equal, so that means I'm allowed to trade them out. So what I'm going to do is I'm going to go take this expression and trade it out for y over here. I'm substituting this in for y. That's going to result in 3x plus 3, and instead of y, I now have 4x minus 4, and that equals 18. So that's the first step. Now I'm looking at one equation with one unknown. The only thing I don't know is the value for x. It's just one variable. I can solve one equation for one variable. That's something I can do. So you have to distribute your 3. I'm going to clean this up a little bit. So I combine the x's. I added 12 to both sides, and now I can divide both sides by 15, and I learned that x is equal to 2. Okay, so I solved for y, I substituted for y here. Now I have an x value, and I can go back over here and replace this x with this 2 and see where I end up. So that is now 4 times 2, that's been replaced, minus 4 equals y. Just clean that up a little bit, and y is equal to 4. So it looks like x is equal to 2 and y is equal to 4. And again, I've just been a little bit of back and forth, and we'll do some more so you'll get to see it, but that's the idea behind it. Never assume you're right, so let's just make sure that we're right. Let's plug it back into both of these equations, and if it's a solution for both equations, it's a solution for the system. So 3 times 2 is 6, and 3 times 4 is 12. 6 plus 12 is 18. It works. Now let's try it over here. 4 times 2, that's 8. So 8 minus 4 is equal to 4. It works over there as well. And I'm just doing that in my head, but you can always check it with your calculator. Not all numbers are this nice. So the idea here is solving, and then you're working back and forth. Like I said, all the work is below the problem, and then you end up with an x value and a y value. And again, don't forget to go back and check it into both of those equations from the beginning.